we are going to talk about setter and getter functions. These are an important way of separating the concerns of different parts of the program. And in particular, the pieces of the program that I really want to separate, and it's really important, are the data, how we store information, and the use of that data. Before we dive into why it's so important, let's start by building a simple example, and as we improve it, we will begin to understand how separating the concerns of storing data and using that data can really help us out. We're going to build a simple program that represents a person's name and gives us the ability to access that person's name and also separate the name into the first name and the last name. So we are going to start by defining a function called print the first name. Now, we're assuming here that there's a variable called name, and that just is a string representing that person's name, like Ben Peterson or Barack Obama or Ronald McDonald. And what I need to do is figure out how to pull out the first name from that person's name. Well, we're just going to look for the space that separates the first name and last name, and we'll then use a little bit of string slicing to pull that out. Notice PyCharm underlined def because I didn't put two blank lines before the def method, which was needed. You're always supposed to have two blank lines before every function definition. All right, let's set the name. Say we'll set it to Ronald McDonald, and print, let's call print first name. We can run this, and when we run this, we get the output here, which is Ronald, which is just what we wanted. All right, let's do the same thing for the last name. I'm just going to write this function very quickly. And now that I've got this function, we can call it, run this again, and now our program outputs Ronald and McDonald's. So everything is fine. What's wrong with this function? Well, with this code. The code works, but the problem is the data representation is tightly coupled to our use of that data. And what that means is, and in fact, the way we actually even ran our program was to modify that variable directly. By tightly coupling all of these elements, the data, the manipulation of the data, and the use of the data, it means that if we want to change any one part of it, we're obligated to change the whole thing. That's not a very good separation of concerns. It would be a lot nicer if we had one part of the code that stores the data, another part of the code that manipulates the data, and a third part of the code that uses it. And as much as we can separate those three things, the stronger our code will be, the easier it will be both to understand and to modify in the future. I'm going to make a number of changes to this code to make it much better code with a much better structure. I've made a copy of this in this second file, and the first thing I'm going to do is I'm going to write a comment here that explicitly says that this is my private storage. This is to be used by the implementation of our name management system, and I don't want anyone outside of our name management code to even know what our storage is. Now we're going to explicitly define an API for accessing the name. And so if we're not going to allow the user of our code to directly access that variable name, then we need to provide an API for letting them modify the name and for getting the current value of the name. And these are very basic ideas, right? You modify data and you access data. And when we make an API for modifying and accessing data, we call those setters and getters. Setters modifies the data, and getters gets the value of data. There's this fancy way of saying we can set data and get the values of data. So to set the data, we can define a variable called set name, and we might give it a name. Our first effort at implementing this is very simple, but it turns out it's wrong. We take the parameter a name and we assign it to the variable name, which is our storage. Notice that PyCharm has colored the variable name as light gray, and if I mouse over it, it tells me local variable name value is not used. And we're like, what does that even mean? This seems strange. This is an important thing, and we're going to get back to it, but let's focus on the API for the moment. So we can set the name and get the name. The next problem with our current set of functions is that our functions print the names. I don't really like that because printing is a side effect. That's doing something to the world. If I'm going to just set and get the data, I would simply really just like to be able to set and get it. If you want to print it, let the person that's calling your code do the printing. Because maybe they want to print it, or maybe they just want to use the name and not print it at all. It's better not to tie your setters and getters to do anything but get and set. So I'm going to change this to get first name. And instead of printing the first name, if there is one, I'm going to return it to the caller. Similarly, instead of printing the last name, I'm going to get the last name, and return it. And now we can separate this third part of our code, which is the code that uses the API. So you can think about this first part of code as essentially as our library. Right? It is a set of code for managing a name. And now down here is our code that uses that API, that library of code. Okay, we can no longer access name directly. Right? Instead, what we should be doing is calling set name and passing in a name. There's no longer a print first name function. Instead, there's a get first name function. That's going to return the value of the first name, and so we can print it. Okay, so we just print the result of calling get first name. Maybe to make it a little bit prettier, I'll add a label. So it'll print first name colon followed by the actual name, and then we'll do the same thing with the last name. All right, this will surely work. I'm going to add one extra nice function because since we are accessing this name as first name and last name, we might also want to access the name as a whole. So we can just define a new function called getName that just returns the name variable. Now down at the bottom here, I can say print whole name, and we'll just call getName, which will get the whole name. Okay, we're almost done. This basically works. This basically will work, except we now have to go back and understand why this name variable is light gray. So we're going to take a break from the API for a second and introduce a new topic, which is scope.
In Python, scope represents the idea that variables can be visible globally, meaning they're visible everywhere, that's called global scope, or locally, or they can be visible only within a function or block of code that they're defined within. And the nice thing about scoping variables is that when you have a locally scoped variable, it's kind of temporary. It's accessible only within that function. And so you don't have to worry about accidentally overwriting a global variable or having some global variable accidentally overwrite or change some little bit of code that you're working on within a function. In Python, the way you distinguish between global and local variables is actually pretty straightforward. You can just define a variable outside of any function, say foo equals 37, and that declares a global variable. And that's mostly what we've thought of our code as doing so far. Here's a global variable called foo. It has a variable called 37. We can print it out and so on and do anything we want with it. It gets a little bit more interesting when we define a function. If we define a function f, and we say xyz equals 42, then xyz is a local variable. It works just like other variables. We can assign it values and so on. But if we were to, say, call that function f, and then print xyz, we would get an error. And the reason is this variable xyz only gets created at the time that the function f is being executed. So it actually doesn't get created yet. When we call f, this code starts executing, xyz gets created, and then the function exits, and all of the local variables defined within that scope get deleted. They go away. And so now when we come back over here and we're back to this top level and we call print xyz, it's gone, and so you get an error. All right, so that's all fine. It gets a little bit more interesting if you want to try and access a global variable from within a function. Because if we're inside of a function, we're in a local scope. So how do we access global things? So Python does two different things depending on whether you are only accessing a global variable or whether you're modifying it. So if you're only accessing a variable, so inside our function, we, for example, say print foo, then that's fine. And when we call f, it will output the value of foo, which is 37. It's a global variable. If, on the other hand, you want to modify a global variable, then it gets a little bit trickier. So let's suppose we weren't printing it, but instead we wanted to modify it. And we said, for example, foo equals 42. And then we said print foo. In this case, if you're modifying a variable, it actually declares a new variable, a local variable. So this would actually create a local variable called foo. It would assign it to 42. It would print it. And then if down here we tried to print foo, it would still print 37 because the global variable foo was never changed. Instead, a local variable foo was temporarily created, and then it actually would get deleted again, and when we come down here, it would print the global one. So what happens if you actually want to modify a global variable from within a function? Well, since modifying variables by default are local, you have to do something explicit in Python to tell it that you want to access a global variable. Let me just sneak some code in here, and you do that with the global operator. You literally just say global space and then your variable name, foo. And that tells the function that foo should not be local. We shouldn't create a new local one. We want to be accessing and modifying the global one. So if we do this and we come down here, we execute it, we print foo, it will have never made a local one. It will actually have modified the global one. So now when we print out foo, it'll print out 42. And that's the essence of local and global scope in Python.
So now that we've seen local and global scope, we can see what's going on with this setName function. When we tried to assign a name to name, it recognized that name was a local variable, right? We're modifying a variable. We didn't say it was global, so it was local. And it grays it out because in PyCharm, it very nicely grays out variables that are assigned but never used as kind of a warning. Hey, what's the point of modifying a variable if you're never going to use it? And this is a hint to us that we weren't actually modifying this global variable, because if we were modifying the global one, this wouldn't have been grayed out. So the way we fix this is the beginning of this function, we say global name. That says we're going to be using the global version of name. And sure enough, PyCharm changes from gray to black, and I think we're good. So now if we try and run this, it works. Whole name is Ronald McDonald, first name is Ronald, and the last name is McDonald. And one of the nice things about this is that our code has no knowledge of the actual variable name, right? We're just using the API. So this code is getting cleaner. But we can still do better. Now that we've got a nice clean separation between the API and the use of it, I can show you one of the advantages of having this separation of concerns. So this code works fine, but every time we access the first and last name, we have to do this work of finding the space and doing this computation, right? In this case, we're only doing it once, but suppose our system accessed the first name a lot, maybe millions of times, over and over and over again for some reason. This code would be really efficient because we'd be doing this work every time we access the first name. Instead, another way to write this code would be to actually split the name up into the first and last name components at the time that we changed the name. So we only had to do that computation once every time the name was changed. Then when you accessed the first and last name, it would be easy because you would store the separate names. We can do that because we've created a separation of concerns between the data and the use of the data. We've defined an API, set name, get first name, and get last name. We don't have to change that. We are literally not going to change a single bit of code in our use of the API. But we're going to change our implementation of this to make it more efficient. So what we'll do is I'm going to break up name into two separate variables, first name and last name. And then what we'll do is when we call set name, we will do that splitting up, that little bit of processing of code, and split it up and store it in first name, last name. In order to do that, I'm going to have to tell the function that I'm going to be using the global versions of first name and last name. And now I can take some of this code that was already existing, modify a little bit, and implement set name. So I'll just go ahead and do that. Alright, so what I've got here is I look for a space, and if there is one, I extract the first name and last name and store it in those global variables. If there isn't a space, then I'll just store the whole name in the first name and say there isn't a last name. Fine. That's set name. Now we have to modify our other functions, right? How do you get name? There's no more name variable. Instead, we have a first name and last name. So now getting name gets a little bit more complicated. I have to return the first name and combine it with a space and then the last name. That's not too hard, and that's not a lot of computational work. But the real savings comes in get first name. I don't have to do all of this anymore because remember I've stored that first name variable. All I have to do is return first name. And similarly, when I can implement get last name by just returning last name. Now we can go ahead and run this and say we'll change this name to make it clear I'm really running new code. Barack Obama, I'm going to run this, and look at that. This code still works, right? We didn't change any of this, well, except for the name that we were testing. So by creating a separation of concerns, we could use our setters and getters for modifying and accessing that data in a way that made the use of it safe and independent of the particular way we decided to store that data. In general, it's always a good idea to separate our code so the way we choose to implement it doesn't change the way that people get to use your code.